Welcome to the deep dive. Today, we're diving into something pretty big.
Yeah.
How machine learning is changing things up, for like all of us in ways you might not expect. Really, it's not just about jobs disappearing, but actually more about like brand new ones popping up.
Yeah, it really is a fascinating shift, and it definitely requires us to think differently about, work and skills in general.
Totally. And to help us like wrap our heads around it all, we've got this super interesting article from Science Magazine. It's called "What Can Machine Learning Do? Workforce Implications." And it was written by researchers at MIT and Carnegie Mellon back in 2017.
Oh yeah, even though it's from a few years ago, the stuff they talk about is still incredibly relevant today. They really went deep on
Yeah.
what actually makes a task, suitable for machine learning, which they call SML.
So instead of us freaking out about robots like taking over the world, we should be thinking more about, which parts of our jobs might become SML.
Exactly. It's not like, poof, all these professions are just going to vanish overnight. It's more like a gradual shift where certain parts of our jobs, you know, might be better done by machines in the long run.
This kind of reminds me of that whole Polanyi's paradox thing,
Hmm.
the idea that we humans like know more than we can actually explain. Like I can ride a bike, but I'd be totally lost trying to like write down the exact
Oh, it's
algorithm for it.
Oh, that's a perfect example. And for a long time, that was a big limitation for computers. We
Yep.
could only program them to do things we understood well enough to, break down step by step. But machine learning is kind of changing the game.
So instead of having to code every single scenario for like riding a bike, you could just like feed a computer a massive amount of data.
Hmm.
Videos of people riding bikes, sensor data, maybe even like weather conditions and stuff. And just let it kind of figure out the patterns on its own.
Exactly. It's like teaching a computer to ride a bike by showing it a million examples instead of giving it this super detailed rule book. And this shift to data-driven learning, it's led to some crazy breakthroughs. Think about how much better image recognition has gotten just in the past few years.
Oh, it's true. Those KPTCHA tests are getting so hard to pass, I can barely tell what's a street sign anymore.
And that's because computers are actually surpassing humans in some of these tasks. They can analyze these super complex images and spot patterns that even trained professionals might miss.
Wow, that's incredible and kind of scary if I'm being honest. What does this mean for people who work in fields like, say, radiology or quality control?
That is the million-dollar question. And to answer it, the researchers in this article, they laid out these 8 key criteria to help us identify which tasks are most likely to be SML, and they're actually surprisingly relatable, even if you're not a tech expert.
Okay, let's dive into those criteria. Then I'm ready to find out which parts of my job might be getting a value. Machine learning makeover.
Okay, so let's break down these 8 criteria. The first few are all about having the right kind of data, for machine learning to actually work.
Okay, so it's not just any data. It has to be specific.
Exactly. The first thing is the task needs well-defined inputs and outputs. It's like baking a cake. You've got your ingredients and the instructions, and then boom, out comes a delicious cake.
So it's good for things that are like structured and predictable, not so much for like, free form stuff like writing a screenplay or composing music, although I have heard of AI doing some pretty crazy things in those creative fields too.
Yeah, it's true. AI is definitely starting to blur those lines. But generally speaking, the more structured and predictable a task is, the better suited it is for machine learning. And that brings us to the second criterion, large data sets. Machine learning is all about learning from data. And the more data it has, the better it can learn.
Like teaching a kid to ride a bike. The more they practice and the more feedback they get, the better they'll become.
Perfect analogy. And speaking of feedback, that's our third criterion, clear feedback. The machine needs to know if it's doing a good job or not.
So instead of a parent like cheering them on, the machine needs some kind of signal to tell it, hey, you're on the right track, or nope, try again.
Think about those music recommendation algorithms, the ones we use every day. They learn from tons of data points about what songs you listen to, what you skip, what you add to your playlists. That feedback loop is what makes them so good at suggesting new music you might like.
It's like a never-ending game of hot or cold, guiding the machine toward the right outcome. Okay, so far we've got well-defined inputs and outputs, large data sets, and clear feedback. What's next?
Number 4 is that the task should avoid long chains of logic. Machine learning is great at making quick decisions based on patterns, but it struggles with things that require complex planning, multiple steps, a lot of background knowledge.
Ah, so it's more of a sprinter than a marathon runner. Good for quick reactions, not so much for strategic planning.
Exactly. Now here's a really interesting one. Explanation is not always crucial. A lot of times with machine learning, we don't really know why it makes a specific decision. It's kind of like a black box.
Like that friend who always gives amazing advice, but can never explain how they came up with it. You just trust them because they're usually right.
Haha, I like that analogy. And in a lot of cases, as long as the machine learning system is producing good results, we don't really need to know the exact reasoning, behind every single decision. Of course, there are situations where explainability is super important, but that's a whole other can of worms.
Okay, that makes sense. So we've covered 5 criteria. What about the last 3?
Number 6 is error tolerance. No system is perfect, so we need to be okay with some mistakes happening here and there.
It's like those self-driving cars everyone's talking about. They're not perfect yet. But if they're statistically safer than a human driver, isn't that a trade-off worth considering?
It's definitely a complex debate with a lot of factors to weigh, but yeah, you raise a good point. Error tolerance is a key thing to think about when we're deciding which tasks are suitable for machine learning.
Makes sense.
Okay.
Okay, so what's number 7?
Number 7 is stability. If the task or the environment is always changing, it's a lot harder for the machine to keep up.
Like trying to teach a dog a trick while you're also playing fetch with it? Too much distraction, not enough focus. The task needs to be relatively stable for the machine learning model to learn effectively.
Exactly. And finally, number 8, no fancy dexterity. Robots are getting better all the time, but they still struggle with tasks that require really fine motor skills or complicated physical manipulation.
So no robot surgeons or concert pianists just yet, huh? Although I have seen some pretty impressive videos of robots doing incredibly delicate tasks.
Oh, it's amazing how quickly things are advancing. But the main takeaway here is that these 8 criteria help us figure out which tasks are most likely to be automated by machine learning, at least for now. And remember, it's not about entire jobs disappearing. It's more about specific tasks within those jobs being transformed.
So instead of asking, will robots take my job? The question becomes, which parts of my job might a robot be better at? And what new skills will I need to learn to thrive in that new environment?
That is the key takeaway. And the article even uses the example of lawyers. Machine learning is already being used to help with things like document review. But it can't replace a lawyer's strategic thinking in court, or their ability to connect with clients or their deep understanding of the law, at least not yet anyway.
This is where it gets really interesting for me. The article talks about how some tasks that we thought required emotional intelligence are actually turning out to be SML, which seems kind of counterintuitive, right?
It does. But think about it. Chatbots are getting crazy good at learning persuasive sales tactics. Just by analyzing massive amounts of data from real conversations, they can spot patterns in language and tone that even experienced salespeople might miss.
Wow. That's both impressive and a little bit unsettling. Makes you wonder, what other skills we thought were uniquely human might be susceptible to machine learning?
And that's not all. The article also talks about how machine learning is pushing the boundaries of computer creativity in some really fascinating ways.
Yeah.
Have you ever heard of generative design?
Yeah, I think so. Isn't that where computers are actually designing things?
It is. You basically feed a computer a set of parameters and constraints, and it uses algorithms to come up with a ton of potential solutions. And some of these solutions can be truly innovative, even better than what the most skilled human designers could come up with.
So a computer could design a better car engine than a human engineer.
It's already happening. The article mentions this example of a machine designing a heat exchanger that was more efficient than any human-designed one. Generative design is being used in all sorts of fields now. Architecture, engineering, fashion, product design, you name it.
Okay, my mind is officially blown. This machine learning thing is way more powerful and widespread than I ever realized. But where does this leave us humans in all of this? Are we all going to be out of jobs?
Not necessarily. Remember, it's about transformation, not elimination. And to really understand the economic side of things, we need to consider 6 key factors.
Okay, I'm all ears. Let's talk about these 6 economic factors. Okay, so we've talked about how machine learning actually works and, the types of tasks it's good at. But I'm curious about those 6 economic factors you mentioned. How will all of this actually play out in the real world for people?
Right. Well, the first one is the one everyone always worries about: substitution. As machine learning gets, better and cheaper, it's going to replace some jobs. That's just inevitable.
Okay, yeah, that's the part that kind of freaks people out. But you're saying there's more to the story.
For sure. The second factor is price elasticity. And that gives us a more, nuanced perspective. When machine learning automates tasks, things often get cheaper. But that doesn't always mean fewer jobs. Sometimes it can actually lead to more jobs.
Wait, really? How does that work?
Think about what happened with digital cameras. When they first came out, they were really expensive. But as the technology got better and prices dropped, more people could afford them. And what happened? The whole photography industry just exploded. More people taking pictures, sharing pictures, needing photo editing software, printing services, the whole thing.
So even though some traditional photography jobs might have gone away, a ton of new jobs popped up around digital photography.
Exactly. And that's the power of price elasticity. When things get cheaper, it can create all these new opportunities and drive demand in ways we didn't expect.
That's a good point. It's not always a zero-sum game, with technology. Okay, so what's the third economic factor we need to think about?
The third one is called complementarity. And this is a big one. It's the idea that some tasks actually become more valuable when other tasks are automated by machine learning.
So instead of thinking about jobs being replaced, we should be thinking about how jobs will change and what new skills will be in high demand because of machine learning.
Exactly. Think about data analysts, for example. As machine learning takes over those more routine data processing tasks, the role of the analyst becomes even more important. They need to be able to understand the results, find the insights, make strategic decisions based on what the machine learning models are telling them.
So it's like having this superpowered assistant that can do all the boring stuff,
Yeah,
which frees you up to focus on the bigger picture.
exactly. And that brings us to the fourth factor, income elasticity. When machine learning boosts productivity and lowers costs, it can actually increase overall income, for some people or even for the whole economy. And when people have more money, they tend to spend it on new things, which creates demand for new products and services. And that leads to new jobs we haven't even thought of yet.
It's like this ripple effect, changing the entire economic landscape and opening up all these new possibilities. It's pretty exciting, but also a little overwhelming to think about.
It is a lot to take in, but that's why it's so important to understand these economic factors. It helps us make sense of all these changes and start thinking about how to adapt and thrive. Now, the fifth factor is the elasticity of labor supply.
Okay, what does that mean?
It basically means how easily people with the right skills can fill those new jobs that are popping up. If there are a lot of people with those skills, wages might not go up that much, even if demand is high. But if the skills are rare and everyone needs them, then wages will probably go up. Basic supply and demand.
So it's not just about learning any new skill. It's about finding the ones that will be most valuable, the ones that are hard for machines to learn and that everyone will need in the future.
You got it. And that brings us to our last factor, business process redesign. When companies adopt machine learning, they often have to completely change how they do things. They need to find ways to integrate these technologies, into their workflows, reimagine their processes, and rethink the roles of their employees.
So it's not just about plugging in a robot and hoping for the best. It requires companies to really rethink how they do things and be willing to adapt.
Exactly. The companies that can adapt quickly and use machine learning effectively will be the ones that succeed. And that means individuals need to be adaptable too. It's not enough to just learn one skill and stick with it forever. We need to keep learning, constantly update our skills, and be open to new ways of working.
So it's not just about technical skills.
Yep.
It's about being adaptable, curious, and open to change.
Couldn't have said it better myself. It's about how we as humans adapt and evolve, in this world of rapid technological advancements.
So after this deep dive into the article and all these complex ideas, what's the main takeaway? What should our listeners be thinking about?
I think the key message is this: machine learning is here to stay. It's going to change everything. But understanding it gives you power. You can make smart choices today to prepare for the future, by understanding how it works, what it's good at, and the economic forces at play.
It's about being proactive, not reactive. Embracing the change instead of being afraid of it.
Exactly. And here's something to think about. What's one skill you could start developing today that would be hard for machine learning to replicate in the next 5 years?
That's a great question for all of us. What are those things that make us uniquely human? Creativity, critical thinking, empathy, problem-solving, emotional intelligence, connecting with others. The list goes on and on. Keep learning. Keep adapting. Because the one thing that's for sure is that things will keep changing.
Thanks for joining us on the Deep Dive.